In this series on Do It, we're going to show you how we were able to CNC mill one of these
and how I 3D printed this.
So you may have noticed that in any of our shots in front of my kegerator, it sits in front of an uncovered electrical outlet. It's a little unsightly. Probably should have done something about it a long time ago. But instead of going out and buying a cover for it, we thought, let's recreate one and compare the differences between CNC milling it out of wood and 3D printing it. This video is in connection with several others in this series, and they make sense when they're viewed together, but you don't really have to watch them in any particular order. At the end, you'll see links to each one of them as well as in the description below. In this segment, what you're going to see is my process for modeling it in Vectric Aspire, as well as the toolpaths necessary to output it on a CNC mill. If you're wondering if we're going to do this two-sided, we're actually not. We are looking at it upside down. So if I rotate or orbit and flip it, you can see our actual cutting side is this guy. So join me and let's see if we can recreate this guy. So in my new job setup, I've got all the defaults ready to go. The thickness of the material of the overall outlet is 0.185, and I just gave a general size here that was larger than the outlet cover needed to be. Needed a little extra height this time because we are going to add the Do It on the top and bottom this time. So here we go. Let's start simple, and we can reference the original SketchUp drawing here. Overall dimensions were 4.7 by 3 inches. And it's already, oh look at that, Aspire remembers everything, how nice. So let's go ahead and create that guy and make sure that it is centered to my canvas by pressing F9. If you don't know that trick, select any vector you want, hit F9, and it goes to the very center of your workspace. Then, the inner area was offset 1/8 of an inch. Why bother doing the math when you can just use your offset tool? 1/8 of an inch inwards, create sharp corners, and we do not want to delete the original. Next, we might as well, let's do that center hole. We got a diameter of 0.135, and oh, Aspire, doing it. 0.135, create. Automatically goes to the center of the canvas, but if you want to make sure, F9, it goes. How about the outlet holes? So this will be pretty simple. Let's make this inner box, which is 3/4 of an inch by 1 1/8. And I'm just going to do this off in space and center it easily later. So the width is 0.75. The height is 1.125, 1 1/8. Create. It's centered it. We need the side arcs here. Overall, from outer to outer is 1.37. What I'm going to do is create a line, a little construction line, that is in the X direction, 1.37. By selecting this, and then selecting that box second, I can use my alignment tool and center it to the selection. Now I have a reference point here, here, and here to create an arc. Real simple. Draw an arc through 3 points. Here we go. Start, end, center. Same thing here. Start, end, delete U. Let's get out our trim tool. Bye-bye, bye-bye. And Aspire is usually pretty smart. Let's see if it joined everything for us. It looks like it did, and indeed we have a closed vector right here. Piece of cake. The spacing between them is 0.415. That's from edge to edge. So rather than manually move it, let's use a copy feature. The array tool here, if I keep my X columns to 1 and rows to 2,
and gap. So the spacing options, you can offset it a certain distance, or you can create in the direction that it's going, it will use the extremities of the shape and create that gap. So it's, again, Aspire has got a great memory from the last model I did, which was this one. 0.415 distance, and it should take it in the positive y direction, and its gap between the extremities should be 0.415. And there you have it. They're both selected, and the beauty of positioning it now is all I have to do is hit F9, because my entire model is centered to the exact center of my workspace. We are cruising. Here we go. Let's arrange our do it letters. Text. The font I've been using is Rockwell, and I think bolded. It is just slightly less bold than Rockwell Extra Bold. So I selected Rockwell, and I think I selected bold. So text height will not be 10 inches. I think we're going to go with, I can't remember if I did 1 before. Let's just try 1 inch and see what happens. All caps, DO for the top, the do. Let's apply. And you know what? I think I did do extra bold last time. Let's compare. Yeah, I definitely did Rockwell extra bold, which is probably smart because of how thin this material is. I want my letters to be kind of bulky, give them a little bit of strength. And while we're here, let's go ahead and create the identical text, identical settings, all caps, IT, apply, and get him down here. Oh, and you know what? Before I forgot, what I did was gave it a little bit of extra spacing. The IT is kind of thin compared to the DO. So what you do here is your text spacing and curve tool. Select the text you want, and notice 2 small arrows between the V and the A are pointing towards each other. If you hold Shift, they point away. So I'm going to hold Shift while I click between the letters and give them a little extra space. I could easily, I'm going to have to convert these to curves. I could easily space them myself later, but it's usually pretty good design practice to manipulate your characters in a consistent way. So now I select Align to the center of the material horizontally. And while I'm here, I'll do the same thing with the DO. There we go. And here, I'm going to creep in to, and I'm just using my up arrow key, and the farther in I zoom, the smaller that step is. And I don't want to perfectly align it. I want it to just overlap just a smidge, and it looks like I have. Right there. That's going to be plenty of grip for the I and the T down here. For the DO, the O is curved, so I might have to overlap it just a smidge more for strength purposes. I really don't want to risk these letters getting broken off. And I'm going to say that that's okay, right there. So now, in order to cut around them, we've got to make sure that they are part of this very outer edge. So the trim tool again, and as we know, it is going to join our sections automatically and close our vector, which is great. So we can safely come in and trim. Let's see if I can get it. It might be dealing with, guess what my problem is? You cannot trim text. It has to be a closed vector, node style. So that's a pretty easy job. Right click, convert to curves. And notice now we have as if they're closed vector shapes instead of text. Same thing up here. Great. Let's try that again. We have a closed vector shape, including our text. Let's keep everything over here on the toolpath side for a little bit and start creating some cuts. I just realized something. This is incorrect. We didn't flip our text. Hold on a sec while I magically change that in 2 seconds. And we're back! Alright, so all I did was undo a bunch of times till it was individual text again, mirrored them. If you don't know where that is, it's this tool right here. And with it selected, I just flipped horizontal about the job center, and then I redid everything to join them to the outside line again. So here we are. Let's create that outer profile. Now, what I was about to say was that I typically do small jobs with an 1/8 of an inch diameter end mill for small profiling. My cut depth is going to be just a hair over the thickness of the material. So let's preview the toolpath. Now, if you were me, you would not be all that pleased with the detail that's going on here. Hopefully, if you have designed before and have cut, you know about the radius of your tool coming into play on interior corners. A great way to preview that is right here in your vector editor, and when you select the toolpath and click down here, this solid option, it's going to create a solid line at the width of your tool and everywhere it travels. So you can see right here, it will not be able to fit because I'm constrained by these vectors, and the radius of the tool won't fit closer into that corner than as is. The easiest solution there is to simply use a smaller tool, but not everyone has smaller end mills than an 1/8 of an inch. I just so happen to have that, so I had to go into my tool library, and if you've never done this before, your tool database, and I've actually imported a whole tool database from a free option online, so I can put that link in the description for you. But even they did not have an end mill option between an 1/8 of an inch and 5/1000ths. So I just took the 1/8 of an inch, hit this copy, and then took the copy and changed the title and the diameter. Now, something you're going to have to remember to do is that if you have specific default spindle speeds and feed rates, you're going to want to change that to your preferences. Personally, I kind of adjust those as I go every time, so I left them alone. I left the step over to 40%, but just make sure that you change the title, make sure the type is still the type that it is, and change the diameter of your end mill. Simple as that. So in this case, let's just go back in, and for me, so you should probably, if you're going to do something like that, buy a smaller end mill. That's how you would add a new tool to your database. Since I've already done that, I'm going to go in and select it, my 1/16 of an inch diameter end mill. Click OK. And we should still be all right going through this in 2 passes with that bit. I'm not 100% sure. We haven't done it yet, but we're going to try it. Calculate again. Yes, it's warning me that I'm going to go through the thickness of my material. It's fine by me. Reset the preview. Let's leave it right here. And actually, let's go ahead and use our 2D, or our solid 2-dimensional profile preview. And you can tell right away that those interior corners are a little tighter than they were before. I'm going to tell you that that's probably good enough for me. Let's do an inner pocket for this guy. Pocketing toolpath. The cut depth is half of the overall thickness of my material. So in this case, that is 0.0925. We'll just stick to an 1/8 inch end mill. 1 pass is fine. We're hardly going that deep at all. I'm going to call this inner pocket. And there we are. So let's go and create another pocket toolpath. This one will use my 1/16 of an inch diameter end mill again, because we want as tight to those details as possible. Cut depth is going to go through the entire thing again, so 0.187. Great movie, by the way, Samuel L. Jackson. Okay, and if we preview those, excellent. since the material around these two outlet holes is already recessed, something to save a little time on those passes would be, so when I go to create a pocket, or I'm sorry, not a pocket toolpath, profile toolpath for those, I'll select these two. I want to be on the inside of those paths, because if I click to the outside, then it will be a larger hole than I initially wanted. So I'm going to click to the inside, my 1/16 of an inch end mill, and now check this out. So rather than going through the entire depth when it's already been recessed, let's go the start depth at what it's been recessed to, 0.0925. And then the remaining depth should be the remaining half, 0.09, and I'm just going to go 4 here. So just a hair over the thickness of the material. One pass is enough. Calculate. It's telling me that I'm going to go through, and in one pass, it takes care of those parts. One thing that we're going to have to remember, let's turn on our solid preview again, is in fact that right here, there is going to be a tiny bit of material remaining. So we're going to test fit it once we've cut it. If it works, it works. And if not, we'll have to do a little manual, maybe a chisel, or I'll make a sanding block, perhaps in that shape, and get the rest of that material out. So that will be an experiment. Let's rename him. Outlet holes. Being that the center hole, we can't just drill a hole straight down. It's an irregular size. So rather than using drilling, I'm just going to use my pocket toolpath again. Select pocket. Maybe let's do the eighth of an inch. End mill, since I'll be using one at another point. And yes, it needs to be the entire depth and all the way through. So start depth will be 0, cut depth will be the entire way through. Center hole. Calculate. OK. Preview visible toolpath. And at this point, we have created almost everything we need to for the entire thing. The most challenging part is yet ahead. So let's create that center ridge. It is 1/4 of an inch in height, and it goes nearly all the way across. And I recall I was just fairly haphazard, just eyeballing how far in we want. So let's just make this nice and easy. Let's go back to our vector editing. And what we're going to do is create vectors that will then become model components, 3D model components. So I'm just going to create a general size here. Let's make sure that its height is 0.25. Let's center it, F9. There we go, real easy, right? But now we need to manipulate it so we're going to have a ramp upwards from the outside inward, and then one final shape in the center that is just a block. So another thing we're going to need to do is create a box that's 1/4 of an inch by 1/4 of an inch. Center him. And we're actually going to have to separate these two into two separate rectangles. So essentially we're going to have 3 shapes in the center. So here's another little trick. Hopefully you know, if you hold control while you do any manipulating or moving of a vector, it will automatically create a copy. So I'm holding control while I grab that grip, and I'm going to bring it right here to that guy and see how he's his own individual shape. I'm going to do the same thing with this overall. Hold control, grab this grip, and snap it to the center point right there. So we're going to use some layers here. I'm going to create a new layer. We're going to call it 3D Outlines. And we're going to put this, the center square, and that side. Right click, move to layer, 3D outlines. And if we blank out 3D outlines, aha, you will see our remaining overall shape. We're actually going to have to add this vector to our inner pocket profile in order to leave it at its full height in the center so we have material left to cut. 3D time. Let's bring back up our 3D outlines. So I'm going to actually blank out layer 1. So all we see is him, him, and him. Could be her. Who knows? Modeling tab. This very first tool, create shape from vectors. If I select it, and I'm going to do one at a time here, we've got this guy, and the base height should be half of the overall thickness of the outlet cover. So that's that. We're going to leave him alone. One thing we do want to do is apply a tilt. So when I check this box and hit set, my tool changes to this cursor with a ruler. And when I click that node, and notice, see how I've got this ruler, and I'm going to go from node, endpoint node to end, and you can see there that from the dark spot to the light spot, it should travel upward, down and upwards to that point right there. So I'll hit apply. All we have to do, now we could easily take this model and copy it just like anything else. The mirror tool, flip horizontal about the job center, and I wanted this time check create mirrored copy. We can safely do it at the job center because remember, everything is centered to our material. Let's rename these. Left ramp, right ramp. Let's create one more shape from vectors. Same settings. No ramp, no nothing. It's just one solid color. And it appears as though there's nothing there, but there is. It's white because it's showing a full height. So we're going to call this, and we're in 3D, right? So let's call it center block. So let's give this a whirl. Let's go over to toolpaths, and what we're going to create now is a 3D finishing toolpath. By default, the first time you click that button, it takes you into material setup. Our thickness of the material is still the same. Now notice it says model thickness exceeds the material thickness. Okay, so let's set the model thickness to what we want, and it's going to be half, 0.0925. Your proper settings are what you want is no gap above the material. Set gap above material to 0. So put the cursor, the option up here, and make sure this is dragged all the way to the top. Okay. 1/8 inch ball nose is probably going to be just fine, so we will leave that. I typically have a 1/16 of an inch boundary offset, which I think we're going to be okay with there. Calculate. In your components, if you double click, the shape height should be our 0.0925, and the base height should be 0. And that should be identical across all three. So now with those settings in place, if we go back to our preview, make sure our preview is reset, and preview all toolpaths. Voila. Finally, if you're going to output this, we need to order our toolpaths so the like functions, meaning functions with the same size bit, are in order, and you can output them together. So let's see, our outer profile should usually be last. The DO pocket, that's done with a 1/16 inch diameter, as is the outlet pocket hole. The center hole is done with an 1/8 inch diameter, as is the inner pocket hole. So it looks like we're going to be changing our bit a couple times. I would put these two together, save toolpath, output of all visible toolpaths to one file, save those. Select these two, they're both using 1/16 inch end mills. Hooray. Save that as one toolpath, and then save this one as one, and this one as one.
Thanks for watching this one till the end, guys, and don't miss out on the other videos related to making one of these. We'll see you next time.